You will have an optimization problem on the AP exam this May, but most students don't have a framework to approach any optimization problem. See if you can solve this problem above. When it comes to optimization problems, the very first step you want to do is to draw a picture, because a picture will detail exactly what's going on in the problem, and if there's anything that may be a bit complex, you can clear it up from the start. So after I've drawn my picture, the very first step I will do next is to identify my optimization equation and my restrictive equation. In this problem, I can tell that my area is my optimization equation. So if you look at the problem again, you can see when terms like the largest, the smallest, the most economical, or the maximum or the minimum are used associated with an equation, that's going to be the thing we're optimizing, and eventually that's going to be the equation we're going to take the derivative of. Now, when we have things that are restricting our optimization equation, like in this problem, we see that our parabola is restricting the area of our rectangle. That is a restrictive equation, and we're going to use that in a second here. Now, the area of a rectangle is x times y, but in this problem, it's a bit unique. So if you need to pause the video, take a moment and see how we're able to create that this area is 2x times y. After that point, our next place in the problem is to move on and replace our optimization equation in terms of one variable. So we're going to take this 2x times y equation and replace that y with some version of x. And it so happens that y is equal to 20 minus x squared. And now in this part of the equation, we replaced y with 20 minus x squared. Now we're going to simplify that to get 40x minus 2x cubed, and then we're going to take that derivative and set it equal to 0. This is the same process of using the first derivative test or finding a max or a min. We're going to find the critical points, and then we're going to make sure that we have, in this case, a max at that point. And we do. So we end up setting this equal to 0, and we get plus or minus the square root of 20 over 3. Now you got to be very careful. We know that x can't technically be a negative number because this is a real life example. So the only number that we're taking here is the positive square root of 20 over 3. And now our final step is to answer the question, and that's what we're doing. We're going to see that the length and the width of our rectangle would be 2 times x, which would be 2 times the square root of 20 over 3. And our width, we need to plug in our equation, our restrictive equation, 20 minus x cubed. When we plug in 20 minus the square root of 20 over 3, we end up getting 40 over 3 as our width. So yes, optimization problems can be challenging, but if you use this framework, it should make it a bit easier. Follow me for more AP Calculus content like this.